The next speaker is Janko, and in his career as an evangelist for Ruby off the Rails, he has been looking at. He's going to talk to us today about how can we overcome some of the issues that we could have, that we will most probably have, and we have had when using ActiveRecord. Sometimes ActiveRecord is great. It's part of Rails, and it gives us a certain interface that we can easily use. But sometimes when you need to push a little bit more and create more complex queries and do some, more advanced SQL stuff, you need to go around the interface of the library, and sometimes write raw SQL. That is always an interesting exercise. To avoid that, you can potentially use other ORMs. The one that Janko will talk us about today is called SQL. Hello, Janko. Nice to see you.
Hello, Monica and everyone.
Welcome.
Thank you.
So this one will be a live talk. So Janko will walk us live through SQL. Remember to ask questions. I will be there looking and listening. In the meantime, I leave you the stage. Thank you so much, and see you in a while.
Thank you, Monica. So as Monica announced, I will be talking about SQL, and it's for me it's been an ORM of choice for quite some time now, and I feel like I've leveled up in using interacting with SQL databases in Ruby in this way, and I want to share some of its features with you today so that you can also learn from it and also take a more critical view whether you want to use an SQL feature or not. So a little bit about me. My name is Janko Marohnic. You can find me as Janko on GitHub or Janko Marohnic on Twitter. I was born in Croatia. Also, I'm Croatian by nationality, but for the past few years, I've been living in Czech Republic. As Monica said, I like to evangelize generic Ruby solutions in my free time. So I write a lot of articles on my blog and occasionally give talks. I also authored many Ruby gems, the most popular being Shrine, which is a file attachment toolkit for Ruby. And in my career, I estimate I had about like three years of using SQL in production. So a little bit of about SQL. It was created in 2007 by Sharon Rosner, and then from 2008, since 2008, it has been maintained by Jeremy Evans. For those of you who don't know who he is, he was a Ruby hero, I think, in 2015. He is the author of numerous Ruby gems, and he is and he is a Ruby committer, I think, as of 1 or 2 years ago. So he's really, really cool person. And like generally about SQL, it's kind of pretty similar to ActiveRecord in the sense that it also implements the ActiveRecord design pattern for accessing data. And it also powers ROM SQL, which is the SQL backend for the ROM RB gem. So this is some example ActiveRecord code, which establishes a connection. So as I was saying, this is some example ActiveRecord code. And when when we write the equivalent SQL code, we can see that it's quite similar. So it also has the notion of models, and it kind of has pretty similar interface. So if you're using ActiveRecord, you should be quite familiar with SQL as well. So in this, throughout the slides, I will be comparing ActiveRecord with SQL a lot. So for ActiveRecord, I will use the blue color, visual cue, and for SQL, I'll use the teal color. Let's start with the design, more specifically the confident design. So usually when you would open a Rails console, you will see and you inspect a SQL or an ActiveRecord model, you will often see this message that a connection has not yet been established. For me, this is a bit surprising considering that we called the method called establish connection before. And in fact, ActiveRecord will establish the connection when the connection object is retrieved as part of a query or something. So it's kind of more lazy in that sense. You also notice that it doesn't immediately define the column methods on the models, but it will actually define them when you initialize a first model instance, which for me is a really is a big red alarm to define methods on runtime. Okay, so if we look at the equivalent SQL code, things will happen when you expect them to happen. So when you call SQL connect, that's the moment when the database connection is established, and that code will fail if the database configuration is incorrect. And then when you create a SQL model, the column methods will be immediately defined on it. SQL's interface is also, API is also more explicit. So this is one typical ActiveRecord code where you would define a query in a controller, and then typically the query would get executed in views. And for me, this is kind of an anti-pattern. I think that controllers, that all data should be loaded at the level of the controller, and views should be working only on loaded data. And the reason for this, while this is a common practice, is that ActiveRecord relation objects act as relations and array at the same time. So when you load records for the first time, the next time you load records, it will return cached results. In SQL, it's the opposite. So SQL datasets, which is the equivalent of ActiveRecord relations, SQL datasets are frozen. So executing any method on it will do the same thing no matter how many times it's called. And in my opinion, this forces you to choose where you want to execute the query. Whether you want to chain more, still more query methods, or you want to actually load the records from the database. And related to that, when we have associations, ActiveRecord will, the main method of ActiveRecord will return a collection proxy object, which then defines numerous methods for querying, retrieving the records. And it also has this multiple purpose of it. SQL is much more explicit here. So the main method for retrieving an association will actually load the associated records from the database. But if you want to chain more queries on the dataset, then you call the underscore dataset method. So you choose what of these two things you want to do. and any association modification methods are defined directly on the model. SQL Design is also much more layered. So in ActiveRecord, you would access pretty much everything through the ActiveRecord base class. While with SQL, you use a database object, which is returned by the SQL Connect method. And you can use these database objects to perform any actions or to ask anything that's not directly related to models, but that's related to the database in general. And in this way, SQL trivially supports multiple databases by calling SQL Connect multiple times and assigning that to different variables, different constants. Here, the DB is just a convention. You can use you can assign it to any other constant or anything else. Then the way that these database objects tie into models is that if you simply subclass the SQL model, it will take the first connected database object. But then you can also pass the database object when defining the model, and that way you can assign different models to different databases. In SQL, the query interface is typically done through models, like it's typically through models. But SQL also, you can also drop down to the dataset level, like to pure database level, in which case loading the records will retrieve Ruby hashes, plain Ruby hashes, instead of model instances. And this shows that in SQL, datasets and models are decoupled from one another. You can use one without the other, or you can use datasets without models. I also really like how SQL handles complexity, since ORMs that handle so many features, they can really grow in complexity. So if you would inspect an ActiveRecord base class, you will see that it defines behavior, that it adds behavior for a lot of features by default, many of which you may not even use. SQL takes a much more simpler, it takes an approach of providing only the essential behavior by default. And then for any additional features, you would load a plugin. And then this plugin, loading a plugin, just essentially extends SQL's core classes with modules. So it adds behavior onto them. So if you wanted for SQL models to have dirty tracking, we would load the dirty plugin. For serialization, we will load the serialization plugin. And we can also opt in for single table inheritance if you want. And for me, like a nice benefit of this is that if you don't use single table inheritance, which will be the case for most of your models, you are free to use the type column. This is something that as a beginner I tripped over many times, that type column is reserved for a feature that I actually rarely use. So essentially, SQL loads much less code by default, and thus is much less complex by default. So let's proceed on to some of the features, feature comparison. And for me, one of the most interesting things is SQL Expressions. So in ActiveRecord, simpler queries, simpler expressions can be presented via Ruby hashes or symbols. But when you want something that can be represented this way, ActiveRecord users typically start using SQL strings. And now, if you are familiar with Arel, you can also use Arel to build these SQL expressions in Ruby. SQL is quite similar to ActiveRecord in this case, but it also provides simpler hash-based expression API. And when you need something more complex, you can use string SQL string literals, but SQL provides a really convenient, really nice expression API that is, for example, we can see that it uses operators in some cases rather than methods, which prevents having to chain things, having to nest things too deeply into parentheses. If this API is too verbose for you, you can also use SQL's virtual block syntax, where you pass a block to a query method, and then SQL will use method missing to instantiate identifier and function objects onto which then you can call methods like normally. And while Arel is mostly works in model context, in SQL you can use expressions virtually anywhere. So here we've defined a unique index, and the condition of where the index will be applied, we were able to use SQL's expression API instead of raw SQL. Another example is that we can also create views using Ruby expressions. And here we can see that this takes two data sets and creates a union, which is really nice. It's really nice to be able to do this consistently. So in my experience, Arel is usually more verbose, where SQL's expression API is more streamlined. Arel is also considered internal API of ActiveRecord, and is not. You cannot find this documentation on API docs, while SQL's expressions are public API. And when I was using Arel, I found it to be very scarcely documented, while SQL's expression API is very well documented. And as I said, Arel usually works in context of models, but SQL's expression API is much more generic, so it's supported virtually everywhere. Another point of the RM is eager loading that I want to touch on. So ActiveRecord provides three methods. Actually, only two ways of eager loading. One is to make a separate query, and the other one is to do a left outer join. So preload will do the first, and eager load will do the latter. And includes will preload by default. Will make a separate query, while if you use references, then it will switch to a left outer join. In SQL, you have only two methods for the two ways of eager loading, and in my opinion, it's much more obvious which one of those does which way of eager loading. So one is eager, the other one is eager graph. What's cool is that SQL's eager loading API also supports adding additional filters or extending the dataset that you are eager loading. So in this example, we are loading associated movie reviews, but only the ones that have been approved. And of course, you can create a separate association definition for it. But it's really nice if you need to use it only at one place, or maybe if you need some external data, that you can define it ad hoc like this. SQL loading also supports limited associations, which is actually something that's not trivial to implement. You would typically think, okay, we just apply the limit to a data set, but that doesn't work. It actually, SQL provides multiple different approaches to doing this, but the default one is to use union all approach. And we can see the SQL generated here. Another thing that I really like about SQL is it's the size of its Postgres specific support for Postgres, for some advanced Postgres features. My favorite is the builder for JSON and array expressions. This allows me to use Ruby instead of cryptic Postgres operators to have to do JSON or to do queries on JSON on array columns, which is really convenient. SQL also provides built-in support for cursors, for cursor fetching, which is faster than limit offset pagination. Basically, it's the way to process large data sets without loading everything in memory at once. But if you want something even faster, you can use the SQL PG extension, which provides the stream method, which is apparently even faster than cursors. And in general, the page each method on models, which is the equivalent of ActiveRecord's find each, will use the fastest solution available automatically. There is also support for copy to and copy from commands, which is usually the fastest way of importing or exporting data from Postgres. SQL has numerous other features, virtually everything that you can think of. Sharding, primary replicas, upserts, listen, notify, common table expressions, prepared statements, window functions, and so on. Now let's talk a bit about performance. And specifically model performance. I've created a benchmark, which I'm showing just the most important part of the code for, is that it just fetches 1,000 articles from, or 1,000 records from a database. So if we measure the execution time compared with ActiveRecord compared to SQL, we'll notice that SQL is significantly faster by default. So in Postgres, it's even, the speed up is even about 2 times faster. And the same is reflected in memory allocations. So for Postgres, SQL will allocate almost 3 times less objects than ActiveRecord. However, ActiveRecord is, I would say that ActiveRecord maybe is cheating a bit in this benchmark, which we will see if we actually load the attributes or the column values from the model instances. So when we rerun the same benchmark, we'll see that ActiveRecord now takes quite longer than it did before. And also it allocates significantly more objects. And the reason for this is that ActiveRecord tries to optimize for that you might not need all of the column values when you fetch records. So it tries to do this allocation and some remaining typecasting and everything. It tries to do it lazily. Whereas SQL loads everything as soon as you fetch the record from the database. So when you call, when you retrieve the column values, it just reads the instance variables with all of the loaded data already ready. For me, this is a preferred approach because it localizes where I'm loading the data. So if, for example, if I'm building a JSON API, and then I'm trying to benchmark why my serializer is slow, I want the performance of that serializer to not be affected by SQLs, by the ORM still initializing some attributes. I want to initialize all attributes in one place, and then I'm done with that, and we can move on. Another interesting thing is that if we load most of the features into SQL that ActiveRecord loads by default, we'll see that it can have significant impact on on fetching records. And mind here that we are not this. We still run the same benchmarks, so we are not actually using any of these features, but they still add performance overhead. And what's great about SQL is that even when your model instances are doing more, and you are running something performance sensitive, such as, for example, a CSV export, you can always opt out of model overhead just by calling naked on the dataset, and then this will return plain Ruby hashes instead of model instances. Another topic I want to briefly touch on is the connection pool. So let's say that we've configured ActiveRecord with default settings, which is a pool size of 5 and a checkout timeout of 5 seconds. So in the example below, we are spawning the threads equal to the pool size plus 1. And in my opinion, this code should run without problems, because once a thread is done using a connection, I think that the connection should be made available for other threads. However, this is in fact not the case. It seems that ActiveRecord will assign a checked out connection to our thread for, I guess, a longer period of time. I don't think it's indefinite, but it's still longer than our example. So the way to solve this problem in ActiveRecord is to check out the connection manually using with connection block, and then this block will check the connection back into the pool once the block is finished. This practice is typically recommended for Sidekick users. However, I consider it a hack. I think that ActiveRecord should be taking care of this automatically. SQL does. So if you run the equivalent SQL code, it will run without problems, even though we have more threads than we have the maximum connections. So in this case, SQL will execute all of the queries. Now, I might have maybe piqued your interest a bit with SQL, but of course, like the question is, okay, but how do I use SQL in Rails? So typically, when you are starting out with SQL, your project is probably using ActiveRecord, so you'll want to the ability to play with SQL alongside your existing ActiveRecord code. Historically, this was a bit problematic because SQL requires its own database connection. So playing with SQL would increase the total amount of connections to your database, and also require some gotchas, or also have some gotchas. So I fixed this problem. I created the SQL ActiveRecord connection gem, which provides an extension which allows SQL to reuse ActiveRecord's connection. So then you can play with SQL in your ActiveRecord project without any without any performance penalty. But you'll often also want to use SQL instead of ActiveRecord, like in some scenarios when ActiveRecord is simply not working for you. And in this case, I would recommend the SQL Rails gem, which provides all of the niceties that we're used to from ActiveRecord, including database reg tasks and generators, some Rails integration, etc. And to use SQL models with Rails form helpers, we just need to load the built-in active model plugin, which makes SQL models quack like active model objects. So this works with both Rails form helpers and with simple form. You'll also need to replace, in this case, you also need to replace some gems that assume ActiveRecord with alternatives that are much more inclusive. So, of course, you won't have direct replacements for everything, but I feel that the alternatives are growing and growing, and both in terms of quantity and quality. So to recap, SQL has a really layered design. It clearly distinguishes between database objects, data sets, and models. I think it really nicely manages its complexity with a plugin architecture. It's the building SQL expression feels really polished in SQL. It also has flexible eager loading options. It offers many advanced SQL features, including a lot of Postgres-specific features. By default, it's significantly faster and lighter than ActiveRecord, and it has a much more reliable connection pool. So that concludes my presentation. Thank you.
Thank you, Janko. This has been eye-opening. For the audience, can you hear me, or is it as terrible as before? I hope not. No, seriously, this has been great. We had 2 questions, but you already answered them in your same issues as before. Let me try with another mic, aka the default one. What about now? Can you hear me better? Perfect. Much better. So whatever happened, happened. So we had 2 questions, and you already answered them in your slides. So extremely thorough. We have yet another question from Slobodan asking, do you have any experience with SQL and Rhoda combination instead of SQL and Rails?
So for Rhoda specifically, I have some pet projects that I've done. So Rhoda is my preferred web framework of choice. So I would ideally use it at work as well. But the closest I used at work was Cuba, which Rhoda was a fork of. And it worked quite well with this. So yeah, I think that Rhoda and SQL work really nicely together. I mean, they're also from the same author. So
therefore, yeah, makes perfect sense. There's yet another question that is rephrasing it a little bit. How battle tested is SQL? Do you happen to know how many companies beside yours are using it?
I know, so I built projects for other companies using SQL. So one personal project was for Apple, then there we worked on an application that used SQL. And I also worked in Clearbit, which is a business intelligence application where the performance was very, like, we benefited a lot from SQL's performance and features and availability. And I felt like we wouldn't be able to do so well if we used ActiveRecord. And I also know for a fact that Heroku uses SQL. So Heroku migrated, when they started migrating from the Rails monolith, they built their microservices using Sinatra and SQL. And that seemed to work really well for them too.
I mean, if it works for Heroku, it's battle tested enough, right?
Yeah.
Yeah. So thank you so much. Looking forward to see you around in the chat and in the hallway track later.
Thank you. It was a pleasure being here, and see you on the conference.